Hello everybody, my name is Nhan. I'm a researcher of Technical Institute from Hanoi, Vietnam. Today I want to tell you about the topic classification performance of binary phase shift keying signals in an autocorrelation receiver. Since in model emitting radioelectronic means, not only simple radio pulses are used, but also complex signals, linear frequency modulation, and phase shifting signals. In the means of radio monitoring, it is required to apply specially for their reception and processing. When conducting radio monitoring in a complex electronic situation, an important question is determining the type of the modulation. Unlike radioelectronic means of location, navigation, and communication, for the means of radio monitoring, the parameters of the signal are a priori unknown. But therefore, their optimal processing is possible using an autocorrelation receiver. However, influence of the different signal code sequences on classification performance of BPSK signals remains insufficiently investigated. This limitation prevents a complete certification of the parameters of the autocorrelation receiver. Purpose of the work shown on the slide. Figure 1 shows structure scheme of autocorrelation receiver. To determine the modulation type in the autocorrelation receiver, the following steps are performed. The first, multiply the signal with its delayed copy. Extract the low frequency component and component at the differential frequency in the resulting spectrum. Double the frequency at the received signal. Multiply the signal with its delayed copy. Extract the low component frequency and component at the differential frequency. Compare the amplitudes of the four spectrum component with the given threshold values and decide on the type of the detected signal. For looking clearly processing detected signal in the autocorrelation receiver, on the slide show us differential frequency in the resulting spectrum of signals. Figure 2 for simple signal. A simple signal is characterized by low frequency component at differential frequency which is close to zero frequency due to the constant carrier frequency. The same is true for the original simple signal at double frequency. Figure 3 for chirp signal. The original linear frequency the linear frequency modulation signal is characterized by the flaring of a component at differential frequency due to change in the instantaneous frequency of the signal during the delay. The low frequency component of the linear frequency modulation signal are close to zero. The same is true for the original linear frequency modulation at double frequency. Figure 4 for binary phase shifting signals. As for binary phase shifting signal, its component at differential frequency after doubling the frequency is close to zero. Thus, by checking the presence or absence of components, it is possible to determine the modulation type of the received signal. Based on the decisions made in threshold device, the modulation type of the received signal is determined shown on the table at the table 1. To evaluate the influence of signal code sequences on the classification performance of binary phase shift keying signals. A simulation study was conducted using the autocorrelation receiver model. The simulation were designed to investigate how the probability of correct classification depends on the structure of the transmitted code sequence under various operating conditions. By analyzing the receiver's response to different code configurations, the study provides a quantitative insight into how code-related parameters affect classification, reliability, and overall system performance. Initial data of the signals shown on the slide number 8. Results modulation shown on the slide. They characterized for different false alarm probability and from figure 5, figure 6, and figure 7, we can estimate the signal to noise ratio and the probability of correct detection equidifference value. And the findings of the investigation into the part of code length on the classification performance of binary phase shift keying signals in an autocorrelation receiver demonstrate that under identical operating conditions, an augmentation in the number of code elements results in a reduction in the probability of correct classifications. The autocorrelation receiver attains high processing efficiency under the condition shown on the slide. A conclusion of the work shown on the slide number 12. Thank you for your attention.